I'm Matt Rowe. I'm a conservation biology major in the graduate program at Central Michigan. I'm actually from upstate New York, and I started my schooling at the State University of New York at Cobleskill in fisheries and wildlife. And then when I graduated from there with my bachelor's degree, I stuck around for 4 years and worked there as a fisheries technician. I was sort of leaning towards away from fish towards freshwater invertebrates, particularly filter feeders, you know, immobile, generally immobile creatures that have a lot of value as environmental indicators. So I was looking at a wide variety of things as far as corals and barnacles and sponges and a lot of things like that. So I found this program dealing with freshwater mussels, and I always kind of liked bivalves, and I thought that'd be pretty cool. So once I learned about their parasitic life cycle and their interaction with a fish species, invertebrate, saw the possibilities there for really interesting research. So that's where I ended up. Well, I'm really looking at gene flow between populations of fat mucket. And we chose fat mucket because they're a pretty common species, and they're a good surrogate for any other species that we might want to look at. And what we're looking at is if the genetics from populations in the streams, like this one here, are mixing with the populations in Lake St. Clair. So we'll be looking at a few different rivers and comparing their genetics to using microsatellites to see if the populations are really distinct. If it's the case that they are distinct, then we need to protect both populations in the lake and the populations in the rivers. If we find that they're really closely related, then maybe protecting both of them isn't so very important.
So in terms of applied uses of conservation genetics data, you're really basically just looking at evolutionary processes, namely gene flow, one of the major factors in evolution, and levels of genetic variation. So
That's right.
it's very applied. It has important consequences for conservation, but really it's very much based on basic evolutionary processes and principles.